Hi, so this is a demo of Kubernetes on AWS using CloudFormation. So we first need to use an environment variable for the stack name. We use Kubernetes test and then deploy AWS, and that started. So it will trigger a new stack here and deploy to new scaling group. And then here, if you look at the parameter, there is a etcd discovery group, which each node running etcd will register to. So what we do is listening to that discovery URL, and once we get all the private IPs, and we define which one is the master, and then from the master we can start all the pod services and replication controller. Note that every time a node is triggered, so by the stack template, and every time the autoscaling will work, static pods will be started by the kubelet, which are cAdvisor for the monitoring and Fluentd for the logging. Everything else needs to be started manually by us to be registered in Kubernetes and available by the kubecfg tool. So we'll deploy them with the start pod script. It takes a while, so let's fast forward. All IPs have been found, and we define the master node. Then we are adding the scaling policies and uploading the config files, which are in the cfg directory. And then every time we will SSH in the master, trigger a new pod or a new service or a new controller. Do it again for the next service. So for the monitoring, we have cAdvisor running as a static pod for every single node. And then we have the influx master, which is the database, backend database, and Hepster, which will get the data from cAdvisor and save it in influx. And then we will have the Grafana interface to see the graphics. Then we have another set, logging, which use Fluentd as static pod on every single node, and then Elasticsearch for the database, and Kibana for the interface to see the graphics. Then we use Docker registry, and once we have the pod running, we can build our custom Docker files and then push them to that private registry, so that later on we can deploy new pods from those private registry images. For the month to come, I believe we will be creating and deleting clusters often to reduce AWS fees. But when a cluster is running, all you need to do is export the stack name of the cluster that you can find here, and then using the command provided by the etc alpaca rc, it will use this CoreOS private key, SSH private key, to SSH in the various instances and do your stuff. So for example, we can alpaca master to SSH the master node, and we'll run kubectl watch list pods, get pods, and we can check on the status to make sure that all containers, all pods become running. So it takes some time to deploy everything. So now that it's running, everybody can git clone the repository and then export, and then use the command to access the database. For example, if you declare f alpaca db, here I'm getting the service IP for the Docker registry, so that I can get the PostgreSQL image from the private registry. Then I get the current PostgreSQL service IP, which IP and port is the server running. And then I SSH on master, and I create a new container, Docker container, which will execute PSQL and connect to the real database. PostgreSQL is still pending, so we'll wait a minute. So on the master node, you can use tools like fleetctl and list all the machines. So you can see we have one master and 2 minions. You can use kubecfg to list pods, get services and stuff like this, but this will become deprecated in favor of kubectl later, so maybe it's good to start using kubectl. Anyway, now we have all the containers running, so we can connect to the database. And we can also start the monitoring tools. So what we do here is SSH to the master while port forwarding the required port to access the Grafana and Kibana interface. So here you see we could successfully access the PostgreSQL database. So it's working fine. And now for the monitoring, you can access it in localhost port 8082, and right now only the cluster CPU and memory is working, so we will fix the rest later. And then for the logging, it's on port 5601, and right now the DNS service on Kubernetes is broken, so we cannot retrieve the logs, but this should be fixed quickly and we will be able to see all that stuff. That's it. So Hitoshi-san, when you want to update the PostgreSQL thing, you need first to update the Docker files on OPT database, and then you need to update the replication controller and services, which are on CFG database controller. So here we define 2 pods by default, and then only 1 container. If you want to add more, you can just list them after that. The port is named PSQL port, and the pod is labeled name PostgreSQL. And then on the database service, we can call the container port PSQL port, and we can select the name PostgreSQL so that it retrieves the correct pod. And finally, if we need a different way to access the PostgreSQL database later, you can update the etc alpaca rc alpaca db function that I explained before, and then if you want to change something for when creating the cluster, you can look at bin start pods. So here I only triggered the controller and then the service, and that's it.